We have a new project. This is our new project. This is called the Obstacle Detector or proximity sensor. So we are making a sensor, obstacle detector, using IR LED, the emitter and the receiver, with only one transistor and some resistors, power LED, and this is our output LED. We're going to power this using 5 volts power bank. Okay. You can see there, here, we have now the power LED that turns on. So when there is an obstacle, piece of paper, it will turn on the LED. Whenever it encounters any obstacle, it detects an obstacle. So that's why it's called the obstacle detector. And it is only applicable for white color. If you're going to use the black color, it did not detect any obstacle. So just a white color. We have now this figure 1 obstacle detector using one transistor schematic diagram. So in our project, we're only using one transistor, NPN type, BC547. What is the project? That is obstacle detector. Oh. So in here we have the 5 volt supply, and then power LED, just to know that the circuit is on, composed of blue LED and 7.5K resistor, just to minimize the use of current by using higher value of a resistor as a current limiting resistor to our power LED color blue. Let us now see the operation of the circuit. So D1 is the transmitter, or we call that LED infrared transmitter or emitter. So if we have this LED, the transmitter, there's an anode and cathode, and this is TX or emitter. It emits an IR, infrared signal. This is a signal or a light, infrared light. So this one is emitting an infrared light towards receiver. So the other one is the receiver. There's also an anode and cathode. Receiver, it receives from here to receiver. Transmit, receive. This is only possible when there is an obstacle. That's the purpose of our project. Since our transmitter is connected to 5 volts via resistor to the ground, so it is always on. So it emits an infrared light to the emitter. But when there's no obstacle, nothing will happen to the circuit. But if there's an obstacle, for example, if we have our hand, obstacle, for example, using our hand, the tendency of the signal is to bounce back to the being received by the receiver. So there is a signal, returning signal to the receiver. This one is transmitter, it receives. Receiver, it is always on. It is only on if there is an obstacle. So there must be an obstacle to make this receiver on. It is only possible to turn on this receiver once there is a current that flows into the receiver, or it will if it receive a signal, the current flows into the receiver, then to the 220k. There is now a voltage division to the circuit. There's a voltage developed at the receiver and then to the resistor, causing the base of the transistor to switch on, because there is a voltage developed across base to emitter, or voltage at the R2 resistor, the same as voltage developed across the base to emitter. If there is a voltage of 0.7 volts developed across the base to emitter, it will make this transistor to turn on 0.7 volts or more. So that is the required voltage to turn on this transistor. Since there's a current that flows into the, as you can see, the orientation of the receiver is, the arrow is pointing towards or pointing to the receiver inward. This one is outward, so it receives, and the cathode is connected to the 5 volts. That is the orientation of the always the receiver. So there's a voltage divider biasing now, voltage across the receiver, then also to the resistor, And there is now a voltage developed across base to emitter of the transistor, which is 0.7 or more, making this transistor to turn on. If this transistor will turn on, will now the current flow into the output side of the transistor, causing the current to flow into the R3 150 ohms, the output LED red, and then collector to emitter. What happened to the collector to emitter of the transistor? It will act as a short, or it will turn on or switch on this transistor, act as a short switch or switch collector to emitter then to the ground. So that's why the LED turns on, and the output is connected here, positive to the 5 volts, and then the negative side connected to the collector. So that is the principle of obstacle detector. Whenever there is a obstacle, the signal is bouncing back to the receiver and being received by the receiver, causing to develop a voltage across receiver and then the transistor. Since there is a current that flows into the two components, a minimal current also, or negligible current also flows into the base of this transistor. But since our biasing, or how the transistor works, or is biased, is through voltage divider, by developing a voltage across base to emitter. So that is how the obstacle detector works, using only one transistor. Okay, and it is only applicable to a white color. If it detects a black color, it is also the same as there's no obstacle. If it detects, it will not detect a black color, because it is also called, or same as there's no detection, or there's no obstacle. Black color, no detection. White color, it can detect white color. Black color, no detection. Now we can let us try using 3.7 volts. So it also works on 3.7 volts and also in power bank. Let us now try the black and white paper. Using black, white. Black. There's no response for the black color. And for the white color, there is it activates the obstacle detector sensor. While black, it does not have a response. White has a response. So 3.7 volts also works.